talk about how it is that we go about assessing intelligence in the psychology field. Okay, so remember that we're going to take a look at intelligence tests in terms of what it is that they say that they're measuring, right? So we see them as methods to assess a person's mental aptitudes, and then ultimately we compare them with others to create numeric scores, or we do use numeric scores to evaluate an individual's intelligence. More often than not, you're looking at a circumstance where the average intelligence is a 100. How that is scored is a little different depending on the time with which we are in history. We used to use a completely different method than what we use now, and that's part of what we're going to discuss for today. So let's talk about Alfred Binet, who is the big gun when it comes to this effort to go about assessing your mental aptitude and ability. Okay, so Binet and Simon, and they're French, obviously, so we actually pronounced as Simon, but they both developed the first standardized intelligence test. Okay, what they were trying to do was identify kids who were struggling in regular everyday classes, trying to find ways to figure out who those students were and then ultimately be able to try to pull them up from that. They were commissioned by the French government to do this. Ironically enough, it's kind of an interesting piece to this, that in many respects what they ended up creating was something that's going to end up putting those individuals at a much lesser leg for things. For example, the Nazis attempted to use the Binet intelligence assessments to identify those with IQ, and there were many conversations that dealt around eugenics, which is basically wiping out those who are of low IQ, killing them because they can't be contributing members to society. But nevertheless, what he tried to do was find a way to measure a child's mental age, okay, which is ultimately the average age of individuals that are of the same age as you that would achieve a particular level of performance, what we would think that a normal individual would be able to complete at that particular age. He didn't create this test to label kids. I just said it before, I'm going to say it again. He warned that the information could be misused if you were trying to use the IQ test to label it. What he wanted to do was find a way to try to help improve the educational experience of those kids who were struggling. Now, Louis Terman is here in the United States, and he's going to be the guy that adapted Alfred Binet's test to create the Stanford-Binet IQ test. He worked at Stanford, so that's ultimately why it got its name the way that it did. You'll hear me talk about Terman as well because he did an awful lot of studying of IQ with regard to giftedness. You'll hear that in some other video notes. And so a form of that Stanford-Binet is still used today. You're going to be able to have access to links to a Stanford-Binet IQ test, so you can kind of see where you fall if you have the time to be able to do that. So the Stanford-Binet is given orally. It varies depending on the person that is taking the test. For kids, they're given figures that they have to copy or everyday problems that they've got to try to solve. But for adults, they have to take a look at and evaluate analogies. For example, explain things like proverbs, describe similarities that underlie any kind of set of words that they're provided with. So, obviously the mental assessment is a little bit higher level for adults. The examiner is going to begin by finding a mental age at which you can answer all the questions. So they're going to evaluate where that baseline mental age is for you. And then they're going to move on to more difficult problems. And then ultimately when your mental age is reached, when no items can be answered any longer, that's when the test is over. Okay? So the formula that was originally created for the intelligence quotient for IQ was created by William Stern, and that is that IQ should be measured as your mental age divided by your chronological age multiplied by 100. Okay, so for example, I'm just going to say that I'm 34 because I'm just a couple months shy of it, so I basically am for all intents and purposes. So let's say my mental age is 34, or excuse me, my chronological age is 34, excuse me. Some would say my mental age is that of a 15-year-old, but at any rate, chronological age is going to go down to the bottom. It's 34. Then I would take a Stanford-Binet, for example. They would assess that my mental age is, rate it what they would expect from a 34-year-old, for example, okay? So then it would be 34 divided by 34, which is 1, times 100, which means I'm at average IQ, because as we've said, average is always going to be 100, okay? And that would be no different. My daughter is 18 months old. If she had the mental age of an 18-month-old, if they completed, a Stanford-Binet test with her, she's still going to be sitting at a 100 as well, okay? We don't compute IQ like this anymore. What we do is we focus on Dave Wechsler's adult intelligence scale and child intelligence scale, so the WAIS for adults or the WISC for kids. So we do the Wechsler scale. Average IQ here is still 100, okay? This is the most widely used IQ test out there. Again, I'm going to have links for you guys if you're interested to be able to take a Wechsler scale intelligence test if you were so inclined and you have the time to be able to do that. The WAIS, I'm going to make reference to it just because you guys are a little bit more along the lines of the adult end of things. It's got two components to it. So there's the verbal piece. You've got to look at things like vocab definitions, comprehension of terms, things like that. And then there's performance. You have to assemble small objects or perform certain tasks, look at pictures and arrange them in a logical order. I'll show you an example of these in a second. And then normally we would take a look at this and see that verbal performance areas are within close range, but separate scores can give a more precise picture of a person's specific abilities. So that's an important piece to take a look at. So when you look at that full scale IQ, there is a verbal IQ score and also a performance score, and then it's broken down into other subcomponents for things to kind of take a look at aspects of how fast you process through something, for example, how you tap into your working memory for some of those verbal pieces, stuff like that. So here's an example of a Wechsler test. So you can see here for that picture arrangement, okay? The pictures below tell a story, put them in the right order to tell that story. So you would be required to then take these images and place them in their appropriate order to make the story make sense, okay? General info like what day of the year is Independence Day, or similarities. In what way are wool and cotton alike? So these are just sample questions for you to take a look at just to kind of get a better feel for what the WAIS entails. So let's talk aptitude and achievement tests, because you do need to know the difference between these guys. An achievement test is meant to be a reflection of what you've already learned. So it is your current level of knowledge. There are any number of examples that you can come up with on that. This would be an AP test because ultimately you are taking a look at your acquired level of knowledge, okay? Any unit test that you take, that's an achievement test as well. Now, aptitude tests are intended to predict your ability to learn a new skill, how well you could do something, for example. So ACT is meant to be an aptitude test in the sense that it is supposed to predict how well you will do in college. Now, if you look at it from that perspective, the example I gave earlier about an AP test would also be an aptitude test, because if you earn a 3 or higher on that test, they would say, look, you would be able to pass an intro level 101 course for something. So it has a little bit of an aptitude component as well. We're going to get into, in class, your opinions about aptitude and achievement tests, because kids have some very, very, very strong opinions on those. Particularly when it comes to that issue of whether they prove what they say they're attempting to measure, because there are some who argue they very much certainly do not. So let's talk about how you construct an intelligence test, all right? And this doesn't go just for intelligence. We'll make reference to this in class too, but the reality is the AP exam, College Board does this with your AP exams in May. Your AP Psych test went through a bunch of standardization, and it is looked at in terms of its reliability and validity when it comes to the scores that it yields. So let's talk standardization first. We'll go through these kind of point by point as they were listed out earlier. Okay, so I'm going to bring this down here first. So standardization is when the test items that are included on a test were piloted on a similar population of people, and they, through that piloting, established norms, okay, or expectations for those questions, okay? So let's talk about your AP Psych test. They gave this test to a bunch of intro-level psychology students in college across the country, to see how they would perform on these test questions. And then they established norms based off of the answers that those kids provided to determine what questions should we include on this AP psychology exam for this year, and which ones should we probably just get rid of, okay? Norms are developed by calculating the average score that's achieved by a specific group, and then each person's score gets compared to see how it differs from that overall average of the group, okay? Particularly when it comes to the people that have taken the test in the past. So an AP test is given to college freshmen as a final exam to set the norms. Back in the day, we used to use the Ohio graduation test, the OGT. Now you have the AIR tests. God only knows what it's going to be in a couple of years when I'm still teaching this stuff, if I'm still teaching this stuff. But the OGT was given back in the day to, say, the class of 2004 to set the norms for what they were going to give when they rolled it out to everybody and implemented it with students starting in 2005. Periodically, the tests are going to be re-standardized. They'll be given to a random representative sample of individuals to then reset and or check those norms that had already been established to see, are they still legitimate, or do we need to kind of change these, adjust the test, et cetera, et cetera. Now, standardized tests will establish a normal distribution curve then, okay? So your scores can be very easily predicted based along this curve. That bell shape is the normal distribution curve. So here is your average intelligence score, which is right in here, which is 100. Standard deviation on an intelligence test, or on intelligence tests in general with our distribution curves, they're going to be 15, okay? So they're measured in terms of 15. So that's ultimately what you should be taking a look at when you're moving forward and doing some of the calculations that are going to be required to understand IQ tests and where a person will fall in terms of percentages. And we'll do some practice on this in class, but it's important to note nonetheless here in our video notes too. Fun little tidbit of info here. In the past several decades, we're running on now almost well over half a century, intelligence scores have steadily gone up by an average of about 27 points. Now, obviously, I mean, the reality is this: the average is still going to be 100, but where they place that in terms of assessment of capacity has changed and altered. And so we call this the Flynn effect, how that has gone up over time. There's lots of reasons why they think that this could be happening. Smaller family sizes, so parents spend an awful lot more time developing and nurturing their children academically, or to help bump up that IQ. People have been going to school for a lot longer now. Back in the 1940s and 50s, for example, you were set for life if you got a job in a factory or something like that. Now those jobs are pretty few and far between. Expectations, societally speaking, is you go to college, and so we know higher levels of schooling equate to higher IQ scores. Better health, sanitation, things like that can help to contribute to that. We know that certain foods, for example, can help to contribute to better brain functioning. So there's any number of things. We're just not totally set on one particular reason why the Flynn effect happens, but it's kind of cool if you think about it. Let's move on to reliability then. All right, so a test is reliable when it yields consistent results. So you've heard me talk about that with Unit 1 when we were covering research. You heard me talk about it when we were listening to info in Unit 10 with projective or objective tests. So to establish reliability, researchers have to do, they're going to do different kinds of procedures. So you could do split half reliability, which is where you divide the test into two equal halves and assess how consistent the scores are. So you take, if it's a 50 question test, for example, you take 1 to 25 in one section, and then 26 to 50 and put that in another section, and then see how consistent the scores are. You do reliability using different tests. So you could have a test A versus a test B form, right? So I've done those in the past. You don't always get the same FRQ as the class that comes after you or even before you. And then you ultimately try to look at the consistency between them, see common threads, because more often than not there are. Just because I change up the circumstances doesn't mean that I always change up the terms that are on there. Something to think about moving into 12, 13, or 14. And then you've got test retest reliability. So you use the same test on two different occasions. So this would be like what your teachers do when they give you a pre-test at the very beginning of the unit before you've covered anything, and then a post-test, which is the actual test itself, right, at the end of the unit to see where is the growth, where is the measurement. You could use that as a form of reliability too. Then you've got validity, because reliability alone doesn't ensure that a test is valid, because validity is that you test ultimately what you say that you are testing, okay? So you're measuring what you're attempting to predict. So when we were teaching this to you back in Unit 1, I said, let's say I give you a test for Unit 1 content. In actuality, I'm giving you a test on Unit 3, and you're getting all these questions on Unit 3. Well, then your results aren't going to be valid, because I wasn't measuring what I said I was measuring, okay? So there are two types of validity categories. You have content validity, which is the extent to which your test measures a particular behavior or trait. So let's say, for example, for our Unit 11 test, my content validity has to be that all of the questions that are on Unit 11's test connect to Unit 11's content, which is intelligence. Then you have predictive validity. So the function of a test is the attempt to try to predict certain behaviors or traits that will be there in future circumstances, okay? So, as we said, reliability doesn't ensure validity. A test can be consistent without measuring what it says that it's supposed to be measuring. So you want to have reliability and validity, okay? Having one or the other isn't necessarily a good thing. You need to have both of those. Is intelligence fixed, or does it change over time? That's often a question that is asked. And to a lot of people, they would look at that circumstance and they would say, well, that seems kind of stupid to ask. Like, you got an awful lot more intelligence when you're a 60-year-old person who's lived on the planet for an awful long time compared to somebody who's a 5-year-old. But here's the thing. It's important to recognize that your type of intelligence is going to be impacted by time. And that's an important component to recognize. So if you remember, back in earlier units, you were taught fluid intelligence and crystallized intelligence. It's back. So let's recap. Fluid intelligence is your abstract reasoning. It's how fast you can process through information, for example. It's your reasoning. It's your memory, okay? How quickly you can kind of access those stores. Here's the thing. Fluid intelligence goes down as you get older, okay? It takes an awful lot longer for my grandpa to process certain things any longer because he's well into his 80s at this point, and his abstract reasoning is a little slow, and so he struggles to be able to understand things like fads, for example. He doesn't understand why some kids wear the clothes that they do. It just doesn't make sense to him. Here's the thing, while not logical, fads are a sign of times, and it's a social component for things. He had fads with regard to certain clothes that were worn back when he was a teenager, but he's not really able to reason through that in that abstract logic now at the age that he is than he would have been when he was younger. Flip side of things, your crystallized intelligence, that's going to get larger or accumulate as you get older, because that's all of the knowledge you've accumulated over life. It's skills, it's strategies that have been learned through different experiences, which would make sense because you've been on the planet for far longer the older that you are, so you've accumulated an awful lot more knowledge or skill set, right? So a 70-year-old could have more crystallized intelligence than a 30-year-old, but they'll have less fluid intelligence because their processing is probably going to end up being a little bit slower, abstractly thinking. So hopefully we didn't motor through this too fast for you. As is always the case, if you got any other questions, let me know. But this is the end of the Assessing Intelligence video notes.